Hello everyone, warm welcome to Multimedia Studio, LNT College, Muzaffarpur. Today we have brought more interesting and analytical topics, that is electrolytic cells, which is another kind of electrochemical cell that comprised electrolyte as a more central medium for the exchange of electrons, right? So in the previous lectures, what I have discussed actually about electrochemical cells, that is zinc copper Daniell cell. In the zinc copper Daniell cell, we have described that what are the thermodynamic concepts and what are the criteria for spontaneous reactions. So that was actually described in more details, right? So in this particular setup, first actually this electrolytic cell means it has electrolyte. Electrolyte means any ionic compounds that is dissolved in water to produce cation and anion. Suppose we have a sodium chloride as a ionic compounds, so that is dissolved in aqueous any water system, then it will produce Na plus aqueous and chloride ion aqueous. So the presence of this cations and anions signifies that the sodium chloride aqueous solution will act as a electrolyte, right? Even you can simply use water, because water contains as H plus and OH minus. So water is itself works as a electrolyte. So first thing here is that this is electrolytic cell, means it has a central part or central role of electrolyte, right? So in another words, you can say electrolytic cell is an electrochemical cell, so that converts, right, electrical energy into chemical energy, right, which is a reverse in case of Daniell or galvanic cell. So here what differences occurs during the setup of such kind of electrolytic electrochemical cell. Here two inert electrodes are required, right? So two inert electrodes are required because it should not interfere with the redox chemistry of electrolyte, right? So suppose we have that is sodium chloride solution or sodium chloride in molten state. Molten state means in the melting form. In the melting forms, so it has sodium liquid and chlorine as gas. So what happens here? We just take one container, right? So containing molten sodium chloride. So this is molten sodium chloride, right? Now we just dip two inert electrodes. So this is first electrode and this is the second electrode. So now these two electrodes are connected by a source of electricity, that is battery, right? So these two electrodes are connected by a external source, so that is battery, where positive polar, this is positive polar and this is negative polar. So one inert electrode is connected by positive pole of the battery, while second inert electrode is connected by negative pole of the battery. Now there is a this is a complete setup of electrolytic cell. So what happens here? Since one electrode is connected with positive pole and another electrode is connected with negative pole, so there is a potential difference between these two inert electrodes. So one electrode acquires positive charge while another electrode acquires negative charge. So this creates differences uh, of potentials, or simply you can say EMF, that is electromotive force, or cell potentials, right? So because of the difference of the electrode potentials in this particular kind of electrolytic cell. So here a battery is actually connected as a external source of electricity. So the use of external electricity is to create a chemical reactions, right? So because in the Daniell cells you have studied that the reactions are spontaneous, means half cells reactions, that is oxidation half cells reactions and reduction half cells reactions, they are taking spontaneously to form a electrochemical cell, and the resultant potential was calculated through the formula E cell is equal to E0 cathode minus E0 anode, where E0 indicates the standard reduction potential. In a similar terminology, here also potential difference is created because of the positive pole and negative pole on this particular kind of these two inert electrodes. So once this inert electrode is connected with positive pole of the battery, then it attains positive charge, right? While second electrode gains negative charge, right? But in case of Daniell cell, what you have seen, the first electrode attains a negative charge, while second electrode attains, that is actually positive charge in case of Daniell cell. So in Daniell cell, spontaneous redox process occurs, right? But in electrolytic cell, is non-spontaneous reaction takes place. It means reaction does not take place spontaneously, rather it is carried out through the use of external electricity or battery, right? So the main use of this battery is to create a potential difference between these two inert electrodes, and this potential difference as a positive charge that is developed on one inert electrode. So this is called anode, right? First or one inert electrode act as a anode. It has a positive charge, while second inert electrode gains negative charge because it is connected with negative pole of the battery. Then it attains negative charge. So it is cathode, right? It means there is a anode positively charged while cathode is negatively charged. Now what happens? Once the electricity is provided, the one electrode gets negatively charged, means it has a high amount of electron on the surface, and another electrode that is actually positively charged, so they have deficiency of the electrons. So because electrons always travel, right, from anode to cathode, right? So this potential difference actually creates and result in flow of electron from anode to cathode, right? So electrons are transferred from anode to cathode, right? So cathode is electron rich and anode is electron deficient. Now this kind of differences of electrons rich and electron deficiency, so that is actually uh, neutralized or exchanged with cation and anions which are present in the molten NaCl or aqueous NaCl, right? So what happens here? Now this sodium Na plus, which is a cation, are actually present in molten sodium chloride or aqueous sodium chloride. Now this Na plus are electron deficient since it has a positive charge, so it easily flows towards a cathode that is negatively charged, and it easily accept electron, right? So then converted back to pure sodium liquid, right? So here this is reduction half cells, and this reduction half cells actually developed in, this is first system and this is second, in the second electrode. So or you can simply say at the cathode there is reduction reactions. So Na plus L plus E minus, that is Na, and the first electrode, that is actually anode, and where oxidation half cell takes place. So chloride ion Cl minus, since it has negative charge, it is electron rich species, it flow towards anode and converted back into chlorine gas by releasing its 2 electron. So this is chloride ion, they flows towards anode where oxidation takes place and it is converted back to chlorine, since here oxidation number is -1 and here oxidation number is 0. So there is a oxidation, right? So this is oxidation half cell reactions and this is reduction half cells reactions, because Na plus has +1 oxidation state while Na liquid has 0 oxidation state. So there is a reduction. So reduction half cells reactions and oxidation half cell reactions are taking place through the application of the external electricity. And what is overall reactions? That is overall reaction, that is called cell reactions. So now here, because in the oxidation half cells reactions there is 2 electrons in the product side, right? But in case of reduction half cells reactions there is only one electron that is exchanged with the sodium cation and sodium liquid. So we have to balance these electrons to neutralize overall the electrons. So we just multiply 2 by the 2 half cell reduction reactions, right? Now 2 Na plus liquid plus 2 electrons, then 2 Na liquids. So just from first and this is second, from first and second we just get 2 Na plus liquid plus 2 Cl minus 2 Na, that is you can simply say this is liquid plus Cl2 gas. Here sodium plus, right, is reduced and chloride ion is oxidized, right? So in overall reactions, that is sodium is reduced to sodium liquid and chloride ion is oxidized into chlorine gas, right? So such type of reactions are carried out, are created through the use of external source of electricity in this particular kind of electrolytic electrochemical cells, right? Now what happens here? Because reactions are not spontaneous, or these kind of reactions are not so easy, so it is very difficult. So here I have used electricity to just create non-spontaneous reactions. Non-spontaneous reactions means as in the thermodynamics, we have studies about delta Z is equal to minus NF E0 cell. Now, in this kind of electrochemical setup, E0 cell must be less than 0, or you can simply say it is a negative quantity. So, in electrolytic cell, the cell potential or EMF of the electrolytic cell is always negative quantity, right? So, overall delta G negative negative, that is positive. So, delta Z is positive. So, it indicates that in electrolytic electrochemical cell, the reactions are not spontaneous, and hence thermodynamically non-spontaneous reactions are taking place because change in standard Gibbs free energy is positive, right? So, the main difference between the galvanic cell and electrolytic cell is that in the galvanic cell, we just create spontaneous reactions to create electrical energy, means chemical energy is converted into electrical energy. But in case of electrolytic cell, the electrical energy is converted into chemical energy, right? Here electricity is used through the battery, and these kind of reactions are carried out in presence of electricity, and these reactions are because of the exchanges of electrons at these two inert electrodes, and the products are obtained, right? So in brief, you can simply say, in case of electrolytic cell, E cell or E naught cell is always a negative quantity, right? But in case of galvanic cell, E net cell is always positive quantity, right? So what happens now? Here we just try to elaborate the electrolytic cell by using water, right? So this is water. Now this water contains H2O, that is H2O means H plus plus OH minus, right? So these are the two ions which are present in water, right? So because of presence of H plus and OH minus, we can electrolyze the water, and after electrolysis of water, the main products which are obtained as uh, hydrogen gas and oxygen gas. So the focus or central theme of the electrolytic cell is to produce oxygen gas and hydrogen gas through the decomposition of water, right? So suppose in case of water, what happens? So water exists as liquid. So this is the possibility of reactions in water, that is 2H2O is converted into oxygen gas plus 4H plus aqueous, that is plus 4 electron. Here the electrons are in the right hand side of the this particular kind of reactions, so it is oxidation. So in the electrolytic cell, the water first get oxidized by releasing 4 electrons, right? So what happens? This kind of reaction occurs at anode. But another possibility is that water may be reduced by just accepting the electrons from the cathode. So 2 mole H2O receives 2 electron converted back to hydrogen gas plus 2 mole of hydroxide aqueous ion, right? So here the electrons are 4 mole and here electrons are 2 mole. So we have to balance these electrons just simply by multiplying by 2 in this particular half cell reactions. So reduction reactions occurs at cathode and oxidation reaction occurs at anode. So this is anodic reaction and this is cathodic reaction. And overall cell reaction is that 2 mole H2O is converted back to 2 mole hydrogen gas and 1 mole of oxygen gas. So through the combination or coupling effect of these two half cell reactions, the overall cell reactions is, that is, hydrogen gas and oxygen gas. Hydrogen gas is just doubled, but oxygen gas has only 1 mole. So this is the beauty, that 2 mole of hydrogen gas can be obtained and 1 mole of oxygen can be obtained through the electrolysis of the water, that is 2 mole of water. Now what happens here is that in the this reactions, that is oxygen gas plus 4H plus aqueous plus 4 electrons, just reverse of this oxidation half cell reactions. So that forms 2H2O. So this is reduction reactions correspond to this oxidation half cell reactions. Now from the electrochemical series, these kind of reduction reactions have a potential, that is E0 equal to 1.229 volt, right? Now another kind of reaction is 2H2O liquid plus 2 electron, so that is H2 gas plus 2 OH minus. So here again this is a reduction reactions. So this is actually obtained by such kind of reactions. So this is your reduction reactions. So here it is as it is such in the case of reduction half cell reaction. So the value of potential or EMF for this particular kind of reduction half cells is equal to E naught is equal to minus 0.828 volt. So what is the potential difference, or you can simply say what is the cell potential? So E naught cell is equal to E naught cathode minus E naught anode, where all these values signifies standard reduction potential. So in case of cathodic reactions, so the value is minus 0.828 volt minus the anodic value is actually 1.229. Overall the difference is minus 2.057 volt, right? Because E cell is negative quantity, right? So it means such kind of reactions thermodynamically unfavorable, right? So they don't occur spontaneously. It means the decomposition of water is not so easy, but it can be obtained through the use of external electricity by set up a electrolytic cell. So once the electrolytic cell is developed by 2 electrodes, then overall reaction, that is 2H2O liquid, 2H2 gas plus this is hydrogen gas and oxygen gas. So hydrogen and oxygen gas can be obtained through the electrolysis of water. So because the production of these two compounds actually creates a potential difference, that is minus 2.057 volt, which is a negative quantity, or simply you can say delta Z will be positive, right? So this reaction is non-spontaneous, so thermodynamically non-favorable, but electrolytic cells are actually used to create the chemical energy through the external source of electricity, right? So now in galvanic cell, as in the previous lectures you have studied that in galvanic cell, that is zinc copper galvanic cell, what happens? Zinc solid was dissolved as Zn2 plus aqueous. It means there is a oxidation half cell reactions. So Zn was dissolved as Zn2 plus, and copper 2 plus aqueous or copper solutions reduced in copper solid. So in the galvanic cell, what happens actually? The one electrode, that is cathode, actually weighted, and another anode electrode, because here zinc is dissolved, so the mass or weight of the anode is actually decreasing, while in the mass or weight of the cathode is increasing, because copper solid is deposited as a thin film on the cathode. So in this particular overall reactions, E0 cell was greater than 0. It means E0 cell was 1.10 volt, right? So here delta G is negative, right? So this reactions thermodynamically favorable, means it is a spontaneous reactions, right? Here delta G is negative. But what happens, if this reaction is reversed, it means then Zn2 plus, right? And once copper solid react with G2 plus aqueous, then it forms copper 2 plus aqueous and zinc solid. So this is in case of electrolytic cell. Here what happens? Copper solid is dissolved, right, as a Cu2 plus, and zinc 2 plus aqueous is reduced as zinc solid. So in a Daniell cell, even electrolysis reactions can be carried out through the use of external source of electricity. So in the previously, the weight of the zinc electrode decreasing, but in case of electrolytic cell, the weight of again the zinc electrode was increased because the deposition of zinc, whereas the weight of cathode was decreased because some cathode, some copper solid gets dissolved into Cu2 plus aqueous system. So these reactions are just reverse of the galvanic cell or Daniell cell reactions. So what happens here? Here E0 cell, that is EMF of the cell, that is actually negative or less than 0, right? So less than 0 means just reverse of these values. It means E0 cell minus 1.10 volt. So delta G will be positive. It means this, the reaction of copper solid with the help of zinc 2 plus aqueous is not thermodynamically favorable. So only it is possible once the electricity is supplied to the reaction medium, then copper solid gets dissolved into copper 2 plus aqueous, and zinc 2 plus just it is easily reduced to zinc solid. So this is the way by which non-spontaneous reactions are carried out through the use of um, external electricity or battery by fabrication of the electrolytic cell, right? So what happens? So suppose we have water, right? So the water contains generally metal ions, right? So metal ions and anions are simply, you can say, water contains H plus and OH minus, right? So if there is a presence of bromine and lithium, that is actually lithium ion and bromide ion as a LiBr salt, then this water actually it can be electrolyzed. So this is the reactions here. Suppose we have a water system, right? So water contains electrolytes in the form of cation and anions. So there is a possibilities of reactions. So the bromine Br2 in a liquid form gets reduced at the cathode by receiving 2 electrons and get back converted into 2Br aqueous, right? Here oxidation number is 0 and here oxidation number -1. So it is a kind of reduction reactions. So the electrode potential or EMF value of this kind of reduction reaction is 1.006 volt. But another kind of possibility is that oxygen which are present in the water, so this oxygen gas in presence of 4 mole of hydrogen ion that receives 4 electron. So this is also another kind of reduction reactions. So that is actually used to convert these reactions into 2H2O, that is water. So such type of reactions generates electromotive force or electrode potential, that is E0 0.815 volt, right? Now another kind of possibility of the reaction is that it may be water just received 2 electron. So they are converted back into hydrogen gas and hydroxide ion, and the electrode potential developed by such kind of half cell reactions, that is E0 is equal to minus 0.414 volt. Now fourth possibility, in the water it may be like that, that is Li plus lithium plus aqueous once receives 1 electron, it is reduced back so as a lithium solid, and the electrode potential developed for this particular half cell reactions is E0 is equal to minus 3.040 volt, right? So these are 4 half cell reactions or reduction reactions, so that occur on the cathode of a electrolytic cell. Now the first possibility is that it may be the production of bromine liquid. So 2Br which are present, bromide ion is present in water, it may be oxidized to bromine Br2 liquid. So this is the oxidation reaction, right? So by releasing 2 electrons. Or another possibility is that water may be oxidized, because both are facing with the challenges with electricity. So these two possibilities, either bromide ion gets converted into bromine liquid or water liquid may be converted back to oxygen gas plus 4H plus aqueous plus 4 electrons. So the oxidation reactions can take place either of these two half cell reactions. Another kind of possibility presents for these systems, lithium cation in the form of aqueous, they receives 1 electron from the external source of electricity, just from the cathode, and then it is converted back into lithium solid, right? So this is lithium solid. So this is also reduction reactions. So this is possibility of oxidation reactions, and now this is possibility of reduction reactions. So in reduction reactions, Li plus aqueous gets converted back into lithium solid, and now another possibility for the water is that water here it is reduced by receiving just 2 electron from the cathode into hydrogen gas and plus 2 mole of hydroxide ion in the aqueous form. So these are the 4 uh, possibilities from these equations, right? Now what happens if there is first chance of production of lithium solid and bromine liquid? ये क्यों नहीं होता? So there is a chance of production of lithium solid and bromine liquid, right? So such kind of uh, electrolytic cell actually consists of overall E0 cathode minus E0 anode, because here lithium plus is reduced, right, and bromide ion is oxidized. So through the oxidation of bromide ion, electrolytic cell produces bromine, and through the reduction of lithium plus will produce lithium solid, right? So here two kind of half cell reaction taking place, that is oxidation half cell reactions and reduction half cells reactions. So this is a there is a complete electrolytic cell. So the complete electrolytic cell means the resultant EMF or cell potential will be equal to E0 cathode minus E0 anode. So in the previous page, the value given is in case of E0 cathode, where reduction takes place, it means 2 Li plus is converted back into 2 lithium solid. So this is a reduction reactions. So here the standard reduction potential for this kind of, it means 2 Li plus plus 2 electron 2 Li solid, right? So this is a standard reduction reactions. So it has a value that is E0 minus 3.040 volt, right? So E0 cathode for one half cell reaction, that is cathodic half cell reactions minus 3.040 minus E0 anode, right? So at as you know that at anode there is a oxidation. So bromide ion is getting oxidized into bromine liquid. So here correspond to these reactions, the standard reduction potential is 1 point that is 1.066 volt for standard reduction of these half cell reactions. So overall the cell potential is minus 4.106 volt. So again it is a negative quantity, signifies that such kind of reactions are thermodynamically non-favorable, or it is non-spontaneous, because it has a negative potential. So it has very high negative potential, that is minus 4.106 volt, right? So another kind of possibility is that water may be uh, decomposed to form hydrogen gas, right, and oxygen gas. So if the electrolysis produce hydrogen gas and oxygen gas, then what will be resultant potential? So in case of water decomposition, the overall this is again minus 1.229 volt. So again thermodynamically non-favorable. So the decomposition of 2 mole of water is thermodynamically restricted because it has a negative cell potential, or you can simply say it has a positive gives free energy change. But again this produces negative cell potentials, so delta G is positive. So this is the case study for the production of hydrogen and oxygen gas, and this is the case for production of lithium and bromine. So for the production of lithium and bromine, here high negative potentials is required, and in case of production of hydrogen gas and oxygen gas, there is a low potential, that is minus 1.229 volt. So compared to these reactions are actually favorables because it requires low potential batteries, right? So decomposition of water is actually carried out because of low potential battery. Third possibility is that here it may be, so this lithium plus is reduced, right? Here 4 mole of lithium plus aqueous gets reduced into 4 mole of lithium solid. So here lithium solid is obtained, lithium metal is obtained, and another is from water contributions, that is oxygen gas, and 4H plus, that is hydrogen ion. So lithium again it is reduced, and here water is oxidized. Here oxygen has -2 oxidation state, here oxygen has 0 oxidation state, right? So now this is reductions and this is actually oxidation, right? So one again there is a complete cell reactions, that is half cell reduction reactions and half cell oxidation reactions, that comprise the overall cell reactions. So what is the resultant cell potential or EMF value? E0 cell will be equal to this value. Again there is a minus 3.855 volt. So again there is a E0 cell is minus 3.855 volt. So this is negative quantity, and this negative quantity signifies that the this kind of reactions actually thermodynamically restricted because of delta G is positive, and delta G is positive means this is non-spontaneous reactions. And fourth possibility is that there may be chance of production of hydrogen gas and bromine liquid. So what happens here? Water again it is that is converted into hydrogen gas, and bromide ion converted into bromine. So here bromide ion gets converted into bromine, that is oxidation, right? And water gets reduced, right? So that is OH minus here. So what is the resultant cell potential? That is equal to minus 1.480 volt. So from these four reactions, what can be concluded here? The lowest potential is required to create electrolysis in a particular kind of electrolytic cell. So the first value is minus 4.106 volt, and second value is minus 1.229 volt, and third value is minus 3.85 volt, and fourth value is minus 1.480 volt. So the lowest potential is minus 1.229 volt. So as you know that in the electrolysis there is a minimum potential which are required to create non-spontaneous reactions, or electricity is actually converted into chemical energy. So for these possibilities, these four kind of possibility, so one of them is very crucial, that is uh, 2H2O liquid gets converted into hydrogen gas and oxygen gas. So the most probability for the formation of hydrogen and oxygen gas will be successful in the electrolytic cell, because it requires lowest potential, that is minus 1.229 volt, and rest of reactions, they actually requires higher negative potential, so they are less significant, and such kind of reactions are highly significant because it produces hydrogen and oxygen gas, right? So this is the case for the electrolytic reactions. So now I think this is so this is overall the chemistry and electrochemistry of electrolytic cell. So electrolytic cell, in brief, you can simply say that in electrolytic cell, the sign of the electrodes actually is reversed to that of Daniell cell. It means anode in Daniell cell is negative and cathode is positive, but in case of electrolytic cell, anode is um, that is positive and cathode is negative, right? And here, in case of a Daniell cell, E naught cell is always a positive quantity, right? But in case of electrolytic cell, E naught cell, E naught cell must come always a negative value, so less than 0. Then only we can say that electrolytic reactions can take place in a electrolytic cell, right? So delta G is always positive for electrolytic cell. Now, so why electrolytic cells are important? Because there is a actually it creates non-spontaneous reactions through the application of external electricity. So first thing is that first production of hydrogen gas plus oxygen gas and oxygen gas, right, through the decomposition of water or electrolysis of water. So this is the beauty, because all we need oxygen gas. So electrolytic cell that produce hydrogen gas. So hydrogen gas actually acts as a fuel, so which is a source of green energy, and oxygens actually we require for all human or living organisms. So this is the most important for the electrolysis of water. Second thing is that such kind of electrolytic cell are actually produced for electroplating, right? Electroplating. What is electroplating? Electroplating, plating means so deposition of or plating of another kind of metal on a another surface. So electroplating means metal can be plated as a thin film on any of the electrodes which are present in the electrolytic cell. And third one is the electro refining. Electro refining, right? So electro refining means non-ferrous metals can be uh, refined through the process of electrolytic cell. Fourth application is that we can get high purity zinc metals or copper metals or silvers or gold or any kind of metals in a pure form through the electrolytic applications. And most important, fifth application is production of aluminum from bauxite, right? Bauxite. So in the aluminum industry, we can produce pure form of aluminum through the electrolysis of bauxite, right? So bauxite is actually ores of the aluminum. So electrolysis is here suitable for the production of aluminum, right? So these are the actually possible applications that is actually required to know the electrochemistry of a electrochemical cell uh, for the electrolytic cells. So I think this much idea and concept will be enough for your level of understanding, and in the next video I will try to explain Nast equations and electrochemical series, so that will give you more insight to understand the electrochemistry in a better way for the application at industry levels. Okay, so thank you. Okay.